introduce myself. My name is Yannis Zgouros. I come from Greece. I am a teacher in high school, teaching physics. And I've started some research for a PhD in nanoscience to investigate, to make research with simple materials. So this is going to be our lab today. And the simple materials that we're going to use will be provided by me. Unknown subjects could be dangerous. We don't know what is underneath this yellow surface. So we have to be very careful with the unknown subject, and we have also to be very careful with lasers. We're gonna use some laser pointers like this, and we won't uncover the symbol. We cannot just move the paper and see what's underneath. That's the easy way. So we are not going to use our vision. Okay? We cannot touch it with our bare hands. It could be dangerous. It's unknown. Okay? It could be dangerous. We will try to figure out what it is with, I don't know, methods and tools. Any method, any idea that you can come up with, it's welcome. Please don't hesitate to tell me. You have also to be very careful not to lose anything. Okay, there are some small things, some small tools, and we have to be careful with this. You can start. Wooden stick, plastic sticks, oven globes. Let's start. Choose any material you think it's useful and start playing with this. Try not to destroy the symbol. You have to be gentle with it. Okay?
I can touch now.
Yeah, but softly. Don't put too much force on it, because we maybe destroy it. And it's really important for our science. Yeah.
I was thinking of drilling.
You're thinking of?
Drilling.
You will destroy the symbol. So, if you destroy the symbol, you won't be able to see what was it.
I want to drill to it to get small pieces to analyze it.
And what if all your symbol is just as small as this one? I mean, if it's something like a bacteria or something, you will destroy, for sure. Okay? Don't push too much force on it. Be gentle with the symbols. I'll give you some student sheets. It's not for homework. It's for now. Okay? I would like you to write down your ideas. How could you take information from me? You have any information that you already get? Just share it with me.
There's something that reacts to magnets, so it's a metal maybe, or
Okay, guys and ladies, do we agree?
What?
It's something that interacts with magnet?
Yes. Yes.
So it's something metal?
Yes.
Okay,
Three metals, three circle metals, I think. In it.
3 circle metals.
And one
And one not?
is not magnetic.
Okay, maybe most of you, by touching the surface, you already saw some kind of circle to be here. A student at your age from Greece did the same thing, and she also found that magnet is the best tool. Okay, she also found, like you, that there's something metal underneath this surface, something circular in size and blah blah blah. But she would like to take more information about where is the exact position. Okay, and she made up his mind with a setup. This is the setup that she developed in our lab. Let's see what it is. It's a laser. Okay, it's a laser source. You will also have it. You will have laser point lasers. I will provide you. This is a symbol.
Maybe.
It's like the ones that you have on your tables. Okay? It's also unknown subjects. And you could turn, yeah, you can come closer if you want. We will get back in our tables later. So, look what she did. A laser source, a laser beam, there is a reflecting surface, a magnet above, a strong magnet, and this is the symbol. So, this surface is reflecting, so the laser beam reflects in this direction. Just imagine, this is a symbol, this is the setup, and we scan the symbol. Okay? We move it in this direction.
Okay.
What do you think will happen to this surface as the magnet is above a metallic material? It will bend down,
Yes.
right? So the reflected beam, it was here when the surface was like this, and when the surface bends down, the laser spot moves
Down.
down, right?
Yes.
And if we leave from the metallic material, it will still again get parallel.
Yes.
So the spot will move up.
Yes. So
And what's the point of it? If we just mark the spots in a piece of paper and we scan all the unknown material by connecting the spots, we will give you the reflecting surface. Okay? It will just be a CD that we cut in this shape. You will just use tape like this. I will give you, it's in the chairs in front of you, to put it this way. Please put the surface that we write, you know, where the data is written, to face up.
Okay.
Something else you have to take care of. Don't put the tape underneath your construction, because we have to move the setup, so if there is tape underneath, it will make it difficult. Okay? So just put tape this and this. Before you put it there, you will just place the magnet. Okay? This magnet, it's not the size that we would like to have, but it's the best option according to size and strength. Put it here and just put a small tape once here and once there. Just take care to leave a surface so the laser beam can reflect. Okay? If you put tape everywhere, the laser won't reflect on the wall. For this very moment, nobody pass the tables. Place these plastic pages underneath your model. Empty the table with any other material, pen sheets, student sheets or whatever. Okay? Now, I need one student from every team. To help me in something. I will pass from all the teams to switch on the lasers, and we have to put the piece of papers on the wall, right? So, somebody has to be from this point reading the measurements. This is 0, this is 5 millimeters, 1 centimeter, and goes on, okay? And you just slide.
One moment.
You don't touch this one. Okay. And team number 3.
Mark the first one.
Tamam. Take it off. Tamam. Tam aldım. Yani 1 santim diyor zaten. Yamuk yani. I don't want to lose them. Don't let anything, please.
You will help me? You take this paper on your table and connect the lines. So, guys from team 1, now we will uncover the symbol and see what is underneath this
Yeah,
surface.
we are really wondering. We are really wondering.
I think it's
Let's see.
different size, two different size money and one something.
3 different sizes of
Money, coins.
coins.
Yeah.
If they're coins, you can have them. Okay?
Okay.
Unfortunately, they're not coins.
Well, they seem like one.
So, there are metallic cups, okay? You see them? 3. And there was a plastic one here.
Yes, I did.
So this
I did
setup
find out.
didn't detect... No.
So don't touch them, they are so dangerous.
Don't destroy the symbol. It doesn't matter if it's not straight. I mean, just a photograph.
Actually, I did detect something that wasn't.
Thank all of you for the cooperation in advance. Now, what does this have to do with nano? Okay? Just imagine that these metal caps are atoms or molecules. Okay? There is a setup called atomic force microscope. This is how it looks like. Quite strange. And this machine can detect nanoparticles. If these are atoms, this is something about 1 nanometer. Okay? Each atom has a diameter of 10 atoms is about 1 nanometer. Okay, so if these are atoms, this machine detects just exactly the same way that we did here. As we detected the metallic caps, this machine detects atoms and nanoparticles. Is that clear? That's the clue of this activity. You detect it with a simple magnet, metallic caps. This AFM, atomic force microscope, detects atoms or some atoms together, nanoparticles, with the same principle of operation. It's exactly the same. How it works? We cannot use vision. We have microscopes to magnify things and see bacteria or whatever, small things. AFM, it's like something touching, but not with our hands. Touching with forces, with magnets. Okay? There is something like a reflecting surface here. It's not a piece of CD. Okay, it's something much more expensive, but it works in the same way. There is a laser beam reflected here and plotted not in a piece of paper in the wall, but in a photodiode, a machine that detects light. Okay, and as this magnet interacts with the symbol, the nano symbol, it moves up and down just like the way our machine did. And the laser spot just moves up and down, like the graph we did. So this machine takes something like this. Isn't really close to your plots?
Yes.
That's how it works. We made an AFM microscope with Lego blocks. The way that we work today is the way that this machine works. And what these guys do? If you take many of these symbols, many of them, one next to another, okay, and you just take one scan, this plot, second scan, second plot, and you just put it one side by side, you can take pictures like this. This is a CD stammer. They just scan this way and they got a graph like the one you did. Then they scan it more, and they just draw the image of the subject that they tested.